Hello, and welcome to the Math Dive in 5 for 4th grade. Use area models to divide multi-digit whole numbers. I'm Shanna Uy. So for your first task, I want you to pause the video. You can complete the task on your own or with a team or partner. Solve for the quotient. For the first one, I want you to use a base 10 model to solve 216 divided by 8. And for the second one, I want you to use an area model to solve 729 divided by 5. As we're working through these tasks, think about how do these two models help us focus on place value as we are dividing in 4th grade? How can I relate the area model of division to the area model of multiplication? And how do base 10 blocks help us transition to array models? I'll see you soon. So looking at the progression with BEST, in 3rd grade, students multiplied two whole numbers from 0 to 12 and divided using related facts with procedural reliability. And they represented those division situations using equal groups models and measurement division models such as number lines. In 4th grade, we're dividing a whole number up to 4 digits by a 1-digit whole number with procedural reliability. And this includes strategies based on place values such as arrays, area models, and partial quotients. And we're also representing remainders as fractional parts of the divisor. In 5th grade, we continue that up to 5 digits by 2 digits, also using that a standard algorithm with procedural fluency, still have remainders as fractions, and we're also multiplying and dividing multi-digit numbers with decimals. During this video, we're going to focus on these strategies based on place value, specifically arrays and area models. Students are already coming in with some understanding of arrays. In 3rd grade, they understood what an array is with 1-digit factors and how both multiplication and division relate using those arrays. So in that first array, you can see it's represented as 8 groups or 8 rows of 3 equals 24. Or I can see the division, I have 24 squares total separated into 8 equal rows, and there's 3 in each row. We're going to continue with that understanding and use the same array models now with multi-digit numbers to relate division and multiplication. So in this model, we can see we have 216 divided by 8, and we're going to use that array to find the quotient of 27, but I can also see it as multiplication. I see 8 rows of 27, which gives me 216. So now we're moving into representing division with base 10 blocks. We want to start by having students represent the division problem using those base 10 models and relating division to the equal groups models that they did in 3rd grade, but now we're doing it with larger numbers in 4th grade. From there, we can move to having those equal groups organized into an array and compare and contrast the two models. What's the same? Well, they both have 216 total. They both have equal groups. What's different? Well, on the left model, I just had them in the equal groups, but in the right model, I've taken those equal groups and organized them into equal rows as an array. Then we can move into actually creating that array as a quick picture. We know our ultimate goal is to give kids efficient strategies that they can use at any time. So if I don't have base 10 blocks, I can now draw that quick picture model. So now that students have had some time to represent division using those base 10 models and moved into creating those arrays, we can take those quick picture arrays that they're familiar with and move into creating an open area model showing those same partial quotients. So you can kind of compare and contrast. In the left model, I have these partial quotients. I have 80 divided by 8 equals 10, 80 divided by 8 equals 10, 56 divided by 8 equals 7. I can see those same exact problems in the open area model. The only difference is I don't have those base 10 pictures inside of it, but I still have the same problems within that open area model. And once again, we're trying to get kids to a more efficient strategy, so that open area model is a way more efficient strategy than drawing that quick picture. So now that kids have had a sound understanding of moving from the base 10 blocks to the arrays to the open area models, now we're going to kind of continue with that. We want to make sure we're making connections to what they already understand about open area models with multiplication using partial products. Now we're doing that same strategy with partial quotients. We want them to compare and contrast and understand that both in multiplication, we didn't know the total or the product. We knew the factors, but not the total. In division, we know that total and we're trying to break it apart and use that area model to break it apart. So now you can see here's the total in the middle of the multiplication one. We didn't know that, that's what we found. But in the division one, that's what we're starting with. And we're trying to take chunks of what we're dividing by until we get to 0 or until we can't divide anymore. So to kind of recap the strategies that we discussed, we have our concrete model, such as base 10 blocks and base 10 block arrays. Then we're moving to our quick pictures or open area models. And then finally, we could just have the equation for abstract thinking or just record the steps of the partial quotients that we did with the open area model. Remember, in order for those bridges to be solid and have a strong foundation, we may need to move back and forth on the bridges and make connections from something in abstract to something in representational and so forth. So just remember, it doesn't mean it's just one-way bridge. You can go both ways on the bridges. Thank you for joining me today for the Math Dive in 5. Use area models to divide multi-digit whole numbers. I hope you got a lot out of this session. See you next time.